It is light amplification by stimulated emission of radiation, right? Am I right or wrong?
Yes, sir.
Yes.
So to work, yes, any doubt?
No, sir.
Okay, to understand the working principle of laser, we need to undergo the quantum mechanical process. Okay, so the quantum mechanical process involves three process, right? Okay, so what are those three process? The quantum mechanical treatments to explain the working principle of laser under process, that is, one is the absorption, other is the spontaneous, and other is stimulated emission of radiation, right? So what is the absorption process? What is absorption process? What is absorption, what is spontaneous, and what is stimulated? So for the lasing action to take place, that particular action should be what type of action it is? For lasing action to take place, what type of process has to undergo?
Stimulated emission.
Exactly. So the emission that should be undergo to obtain the lasing action is the stimulated emission, right? So what is the difference between absorption process, spontaneous process, and absorption process, or stimulated emission process? What is the difference? What do you mean by absorption process? See, let us consider two energy levels. Okay, so the energy level at the ground state and the energy level at the excited state, right? So let us consider an atom or electron in the lower energy level. Okay, so when an energy of h nu falls on the atom in the ground state, so the atom or the electron absorbs the whole energy, whole incident energy incident on it, right? As soon as it absorbs, right, as soon as it absorbs the whole energy, it jumps into the higher energy state, correct? Is it right or wrong?
Yes, sir.
Right. So when it jumps to the excited state, so that process is what we are calling it as the absorption process, because the total energy that is incident on the atom, so the atom totally absorbs the incident energy. So that is what we are calling it as total absorption process. Okay. So what happens in case of spontaneous emission? Spontaneous emission, what happens in terms of spontaneous emission? So the energy, the electron or atom at the excited state suddenly spontaneously falls to the ground state by releasing only small amount of energy, that is releasing only one amount of photon. Correct?
Yes, sir.
So this type of process is called the spontaneous emission process. Whereas in stimulated emission process, the atom or the electron at the excited state needs to be stimulated, right? The atom or the electron that is at the excited state needs to be stimulated. That means some action, some energy is required for the atom or the electron in the excited state to come to the ground state, right? So that type of process is what we are calling it as stimulated emission process. So during the stimulation emission process, what is happening? What is happening compared to spontaneous? What happens there? ఏమైతుంది అక్కడ ఎంత ఎనర్జీ రిలీజ్ అవుతోంది స్టిమ్యులేటెడ్ ఎమిషన్ లో?
maximum
ఎనర్జీయా? మాక్సిమం ఎనర్జీ ఇన్ ద సెన్స్ ఎనర్జీ ఎక్కువ రిలీజ్ అవుతుంది కంపేర్ టు స్పాంటేనియస్ ఎమిషన్ లో 1 ఫోటాన్ రిలీజ్ అయితే స్టిమ్యులేటెడ్ ఎమిషన్ లో ఎన్ని ఫోటాన్స్ రిలీజ్ అవుతాయి?
2 photons
2 photons. So there we can observe some large amount of energy. So hence for the amplification, hence for the laser, so the amplification process is done by what type of emission? Stimulated emission process. That's why we are telling it as light amplification. Light is amplified by a process called stimulated emission. So we call it as light amplification by stimulated emission of radiation. Okay. So what are the characteristics of lasers? What are the characteristics of lasers?
Coherence.
Yes.
High
Coherence,
directionality,
and
brightness,
high intensity. Okay. Coherent. Coherent. What do you mean by coherence? When can you tell a light is coherent?
When they are in phase.
Very good. When they are in phase, that means it should amplify. It should have constant phase difference. It should have constant phase difference. Okay. Okay. So the light that is getting stimulated down, okay, the light that is getting stimulated down to the ground state is in phase with the incident photon. Okay, is in phase with the incident photon. That's why it immediately reaches the ground state by releasing large amount of energy. Okay, that's why this particular lasing action is done by stimulated emission process. That is one of the important characteristic, that is coherence. Coherence is one of the important characteristic property of laser. Clear? Is it clear?
Yes, sir.
Yes, sir.
So that is what laser, just to go through it, I have shared some slides. So light amplification by stimulated emission of laser radiation. Yesterday we have seen this. A laser is a device that can produce a very narrow intense beam of monochromatic coherent light. Okay, so what is the first laser that was invented? It is nothing but the Ruby laser. Okay, it was the successor of Maser. It was the successor of Maser. So laser was introduced by whom? T.H. Maiman. Okay, Maiman is the person who has invented it laser, who has given the working principle. Okay, so why we are telling that the three process, that is absorption, spontaneous and stimulated emissions, are quantum mechanical process, because why we are telling it as quantum mechanical process? It includes the theory of radiation. It includes the Planck's theory of radiation. Okay, so is the reason we are telling that to understand the working principle of laser, we need to go for the quantum mechanical principles. Okay, so that is the reason. Next. Right. So what are the characteristics? Right? Characteristics of laser are highly monochromatic, highly directional, high intensity, and high coherent. Right. So these are what the transitions are. Some cases we have seen yesterday. One is absorption process, other is spontaneous emission, other is stimulated emission. So see here, just I'm repeating once again the diagram. Okay. So here you see, so this is your ground state and this is your excited state. Okay. So some energy is given to the atom. Yes, Satvik, what is the problem? Babu.
Nothing, sir. It's by mistake. Sorry.
Okay. So here we have the ground state. There is an atom. Some energy is given to the atom in the ground state. Say atom or electron in the ground state. It excites to the excited state. So after the time at which the atom stays in the excited state is called what we are calling it as lifetime. Okay. After reaching the excited state, it immediately reaches the ground state by releasing only one amount of energy. Okay, that is what emitted photon of energy. Can you see on the screen? Can you see on the screen?
Yes, sir.
So that is what the case is. Okay. So whereas in case of stimulated emission, the atom at the excited state is given some sort of external energy. Some external energy is given to the atom at the excited state. Okay, so is the reason it runs to the ground state by releasing some amount of energy. Okay, so that is what we are telling here. Only one photon is released. In other case, we are observing only 2 photons. Okay, so this is what the transitions. So this is what the transitions we observe. So absorption, spontaneous and stimulated emission transitions. Okay, right. So yesterday we have gone through this particular differences between the spontaneous emission and what is that stimulated emission. Spontaneous emission takes place when excited atoms make a transition to lower energy level without any external simulation. Okay, but without any external stimulation. So stimulated emission takes place when a photon of energy equals to h nu stimulates an excited atom to make transition to lower energy level. So this is polychromatic radiation and this is monochromatic radiation. Right here in spontaneous emission we observe less intensity, whereas here we observe the high intensity. right? So the other property which differentiates is it has less directionality, more angular speed during propagation, high directionality, so less angular speed during the propagation. So it is spatially and temporally incoherent radiation. It is spatially and temporally coherent radiation. This is what the important difference, which is shows a similarity, that is spatial and temporal coherence. So examples, light from a ordinary source is what is due to the spontaneous emission. So light from a laser is what comes from the laser. So that is what the process is called, a stimulated emission. Okay. So these are the differences we have seen yesterday, right? Okay. So now let us discuss some of the other parameters that are included in laser. So the other parameters or the other properties of laser. Okay, so other properties or other parameters that are included in laser are, first one is the metastable state. Okay, what is the first one? First one is the metastable state, and other is the population inversion. Okay, so what do you mean by metastable state? See here, I'm telling you. So the excited states, okay, the excited states which have a longer lifetime. Okay, the excited states, the atoms which have a relatively long lifetime due to slow radiative and non-radiative decays are called the metastable states. Okay, so the lifetime of a metastable state is 10 power minus 6 to 10 power minus 3 seconds. Okay, so what is metastable state? See here, I'll tell you. See, so this is your lower energy state, and this is your higher energy state. So this is what we are calling it as E1, and this is what we are calling it as E2, right? So the atom in the excited state. So let us consider there is an atom in the excited state. Okay, so the lifetime of the atom at the excited state is very less. Okay, the lifetime of the atom that is staying in the excited state is very less. Okay. Okay. So to make the downward transitions, okay, to make the downward transitions, the lifetime of the atom at the excited state should be more. Okay, you understand this point? Initially, the atom that is excited to the excited state, okay, after the absorption process, okay, so the lifetime of the atom at the excited state is considered to be as very low. Okay, but to observe the lasing action, right, so we need to have the lifetime of the atom or the electron should be high. Okay, so in order to achieve the lifetime of the atom in the excited state more, we need to create one more state. Okay, so that state is what we are calling it as the metastable state. So where we are trying to put that metastable state is, we will try to put that metastable state is somewhere between E1 and E2. Is that understood? Is it clear?
Yes, sir.
Okay, so why we are putting metastable? That's what we are telling. The excited states which have a relatively long lifetime due to slow radiative and non-radiative decay are called the metastable state. So the lifetime of the metastable state is around 10 power minus 6 to 10 power minus 3 seconds. Now, when the atom in the excited state, when the atom or the electron in the excited state, to make the downward transition, the time period or the lifetime of the atom at the excited state should be more. Okay. Okay, lifetime is so but it reaches spontaneously to the ground state. Okay, only by releasing some small amount of energy, but that is not the considered principle for lasing action. Okay, so to observe the lasing action, right, to observe the lasing action, we need to put one more state that is called the metastable state, where we can observe, where we can change or we can observe the lifetime of the atoms or the electrons is more compared to excited state. Okay, if we put one more metastable, if we put a metastable state, so at metastable state, the atoms or the electrons at the metastable state, the lifetime of the atoms at the metastable state are more. Okay, the lifetime of the atoms or electrons in the metastable states are more. How much it will be? It will be around 10 power minus 6 to 10 power minus 3 seconds. Is that clear?
Yes, sir.
So when the lifetime of the atoms or the electrons at the metastable states are more, right, then we can observe the downward transition. Okay, then we can observe downward transition. That means we need to stimulate the atoms at the excited state, at the metastable state also. Okay, we need to stimulate the atoms at the metastable state also. When the atoms get stimulated at the metastable state, then only it reaches to the ground state. Okay, the importance of putting metastable state is to increase the lifetime of the charge, to increase the lifetime of the electrons or atoms. Okay, to improve the lifetime of the atoms or the electrons at this state. Okay, so that state is what we are calling it as metastable state, right? So when the atoms or the electrons try to accumulate at the metastable state, then the population of the atoms increases. So that is what we call it as population inversion. So usually in a system, the number of atoms N1 present in the ground state is larger than the number of atoms N2 present at the higher energy state. Okay, so the process of making N2 greater than N1, the process of making N2 greater than N1 is called the population inversion, right? The process of making N2, that means N2, what is N2? Number of atoms present in the higher energy state. The number of atoms present in the higher energy state. So that is what we are telling. The process of making N2 greater than N1 is called the population inversion. So what are the conditions for population inversion? See, to obtain the conditions for population inversion, the system should possess, okay, the system should possess at least a pair of energy levels. Okay, a pair of energy levels in the sense we need lower energy level and at the same time we need the higher energy level. We need the pair of energy levels. That is what we are writing. The system should possess at least a pair of energy levels. Okay, that is E1 and E2, provided E2 should be greater than E1. Provided E2 should be greater than E1. Okay, and this is separated by an energy equal to the difference of the energy levels. Okay, is equal to the energy of the difference of energy levels. So that difference of energy levels should be equals to h nu. That difference of energy level should be equals to how much? H nu. What is h nu? H nu is nothing but energy of the photon. H nu is nothing but energy of what? H nu is nothing but energy of what?
Proton.
Proton kadra babu, photon, 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 not photon. Okay. So that is what. So that is what we are telling. Okay. So usually in a system, the number of atoms N1 present in the ground state E1 is larger than number of atoms N2 present at the excited state. So the population, the process of making N2 greater than N1 is called the population inversion. So conditions for obtaining the population inversion are, the first one is the energy levels, right? The difference of energy levels, E2 difference E1 should be equals to the energy of a photon, right? So that is what the system should possess at least a pair of energy levels, right? That is E1 and E2. Okay, it should be greater than, that is E2 should be greater than E1, separated by an amount of energy equal to the energy of photon. That energy of photon difference, the energy of a photon is equal to the difference of energy levels, that is E2 minus E1. That is what we are writing. E2 minus E1 is, E2 minus E1 should be equals to h nu. E2 minus E1 should be equals to h nu. Okay, if this condition is satisfied, this condition should be satisfied. So to obtain this condition, to get satisfied, we need to put the energy levels, that is E2 should be greater than E1. If E2 is greater than E1, obviously N2 will be greater than N1, right? Because N2 is the number of atoms or electrons present in the E2 level, and N1 is the number of atoms or electrons present in the E1 level, right? So that is what, if E2 is greater than E1, obviously N2 will be greater than N1. So that condition is what we are calling it as the population inversion. So that is what, that is one of the condition to achieve the population inversion. So what is the other condition? The other condition is there should be a continuous supply of energy to the systems. There should be continuous supply of energy to the systems such that the atoms must be raised continuously to the excited state, right? There should be a continuous supply of energy to the system such that atoms must be raised continuously to the excited state. Okay, so that means if you take E1 and E2, E1 as the lower energy level and E2 as the higher energy level, if there are number of atoms in the E1, okay, so the number of atoms in the E1 to get excited to the excited state, continuous energy is required for the atoms or electrons present in the ground state, that is E1. Okay, so continuous energy should be given to the atom. When we give continuous energy to the atoms in the ground state, obviously it jumps to the excited state. It jumps excited states. That's why, so there should be a continuous supply of energy to the system such that atoms must be continuously raised to the excited state, right? So there could be a condition called population inversion. There could be a condition of no population inversion, right? So there could be a condition of no population inversion, and hence no laser action takes. Okay, hence no laser action takes place if metastable state do not exist. Okay, that's why the importance of putting metastable state is to increase the life carriers and to take the downward transitions very fast. Okay, so there could be no population inversion and hence laser action. Okay, and hence no laser action takes place if metastable state is not there. Okay, so that means if you see here, if this is E1 and this is E2, so the number of atoms in metastable state are more because the life carrier is the lifetime of the atoms will be more here. Around how much it is? Around 10 power minus 6 to 10 power minus 3 compared to the excited state. That's why the number of atoms at the metastable state will be more. Okay, that means the population of the atoms at the metastable state is more. Okay, so to achieve lasing action, what is to be done? Each atom in the metastable state should be get stimulated. Why it should get stimulated? To make the downward transition. Okay, why it should get stimulated? Stimulated to achieve the lasing action. The atoms at the metastable state should be get stimulated so that it reaches to the ground state. Okay, so that is the condition. There should be no population inversion and hence low laser action. Okay, if metastable state exists. Okay, if metastable state do not exist. Okay, so that is the importance of putting metastable state. Okay, is it clear? Is this clear? Metastable state and population inversion.
Yes, sir.
Shall I go to the next slide?
Yes, sir.
What happened to the remaining?
Yes, sir.
Okay. Right. So now we shall see what are the methods. What are the methods to achieve population inversion? Okay. So the methods are to achieve population inversion is called the pumping. Okay. So we told that at the metastable state, the population of the atoms or the electrons will be more. Okay. So electrons or the atoms present in the metastable state are more. That means the population of atoms or electrons at the metastable state is more. Okay. So to get a downward transition or to get stimulated emission, right, the atoms or the electrons need to be pumped. Okay, so we need some energy source for the atoms or the electrons present in the metastable state, right? So one of the method to achieve, okay, the population inversion, okay, is called the pumping. For maintaining a state of population inversion, atoms have to be raised continuously to the excited states. That means it requires energy to be supplied to the system. Okay, so the process of supplying energy to the medium with a view to transfer it to state of population inversion is known as pumping. Okay, simply the process of attaining population inversion is called pumping. Okay, so these pumpings are of how many types? These pumpings are of 5 types, right? Right, what are those? One is optical pumping, other is the electrical discharge, atom-atom collision, direct conversions, chemical reactions, and injection current. So these are the different ways which we can observe the population inversion mechanism at the metastable state. So that is what, for maintaining a state of population inversion, atoms have to be raised continuously to the excited state. Okay, so it requires energy to be supplied to the system. Okay, so the process of supplying energy to the medium with a view to transfer it into state of population inversion is known as pumping. Okay, so this pumping can be achieved by different methods. One is optical pumping, other is electrical discharge, other is the atom-atom collision, direct conversion, chemical reactions, and injection current. So what are the methods? What are the ways we can achieve the pumping mechanism? What are the ways we can achieve the population inversion? The methods to achieve population inversion is by pumping. So the pumping can be done in different ways. What is by activating the optical energy, electrical energy, atom-atom collision, right? The energy released due to atom-atom collision. So that also can be used as the energy to make downward transition. Okay, so other is chemical reaction, other is the injection current. So these are the different ways of obtaining pumping mechanism. Okay, now if we come to the components of a laser, so how many components are there? So in the laser, how many components will be there, right? So we have different components. What are those components? So that is the first one is the optical cavity will be there. Okay, other is active medium. Okay, laser beam, mirror, partially reflecting, 100% reflecting, mirrors, active medium, pumping. Okay, so these components of laser, there are three main important components. One is active medium, okay, other is the pumping mechanism, and other is the laser beam. Okay, these all are enclosed in a optical cavity. Optical cavity in the sense a glass-like case, right? So the main components of laser are this one. Okay, so this is all placed in a optical cavity. Okay, so these are the mirrors. So this is one mirror, this is other mirror. Okay, so these mirrors are used as perfectly reflecting mirror. To get the lasing action, we need to pump the active medium. Okay, to get the lasing action, we need to pump the active medium. When we pump the active medium, okay, some laser beam will be ejected out. So this lasing beam, okay, when it is ejected out, will be reflecting from the mirror. Okay, so that is what we are using it as a mirror. That is why we are putting 100% reflecting mirrors. Okay, and this is partially reflecting mirrors. So the basic components of laser are active medium, pumping mechanism, okay, active medium and pumping mechanism, and the components that are included are reflecting mirrors, partially reflecting mirrors. Okay, the whole system is integrated in a cavity called optical cavity. That is what optical mirror, right? Clear? So these are the components of laser. Okay.
Yes.
Right. So what are the different types of lasers? What are the different types of lasers? We have solid laser, gaseous laser, liquid laser, dye laser, and semiconductor laser. So these are the different types of lasers. Okay. So in our present syllabus, we have only the solid laser. Okay. So this solid laser, solid laser is nothing but ruby laser or ND-YAG laser. Okay. Ruby laser and other is ND-YAG laser. We have to see what is this ruby laser and ND-YAG laser. I don't think so. ND-YAG laser is there. Only ruby laser is there. The other is gas laser. Gas laser is nothing but carbon dioxide layer. Carbon dioxide layer. Huh? And Babu? Yes, చెప్పండి. చెప్పండి. చెప్పండి ఏంటి ప్రాబ్లం? వాట్ ఆర్ సాలిడ్ లేజర్స్? సాలిడ్ లేజర్స్ అంటే ఏంటి? రూబీ లేజర్ అండ్ ND-YAG laser. ND means neodymium. Okay, neodymium. YAG means YAG అంటే ND-YAG laser అంటాం. YAG అంటే YAG. What do you mean by YAG? ND-YAG laser. So what are gas lasers? Gas lasers are carbon dioxide laser, CO2 laser, or argon ion laser. Argon ion laser is nothing but helium neon laser. Okay, helium is an argon gas, right? So that is what we are calling it as helium neon laser. Okay, other is carbon dioxide laser, other is argon ion laser, that is helium neon laser, and other types of lasers are liquid lasers. Liquid lasers are nothing but europium chelate laser and cerium octalate laser, SeO-Cl2 laser. So there is dye laser. Dye laser as rhodium 6G dye laser and chromium dye laser. So other one is a semiconductor laser. It is indium phosphate laser or gallium arsenide laser. So these are the different types of lasers. Okay, so solid, liquid, gases, dye lasers and semiconductor lasers. So these are the different types of lasers. Okay, so if we come to any doubt? Yes, any doubt?
No, sir.
Shall we go ahead?
Yes, sir.
So let us go for the ruby laser first. Okay, so as I told you, what are the components of laser? The components of laser are, what are the components? In the previous slide we saw the components of laser are the optical cavity, pumping, okay, active medium, pumping, and mirrors. So these are the different components of laser. One is the optical cavity, that is what we call it as resonator cavity also you can call. Other is a other are the mirrors, and other is the active medium, and other is the pumping mechanism. Okay, so these are the two types of mirrors where we can place. Okay, in between the two mirrors we are placing the active medium. So to activate the energy levels in the active medium, we need to pump that particular medium. Okay, so these are what this is what I told you. Pumping can be done in 6 or 5 types, right? What are those? One is the optical pumping, electrical discharge pumping, atom-atom collision. Okay, cathode ray. Other one is atom-atom collision, direct conversion, chemical reaction, injection, current. So these are the different pumping mechanisms. Okay, these are the different pumping mechanisms to pump the active medium. Em pump cheyaladi active medium. Active medium ante enti? What do you mean by active medium? Active medium means, see here, in ruby laser or in any other types of lasers. So this is what we have seen, that is gaseous laser. In gaseous laser, we are telling that helium neon. So helium neon. So in this active medium is helium or neon. Okay. In ruby laser, we have certain materials. It's a combination of aluminum and chromate. Okay, aluminum and chromium. So these are the active components. So that is what, sorry, these are the active medium. So in gas laser, we are telling carbon dioxide laser. So carbon dioxide is acting as a active medium. Okay, so that is what we call it as active medium. To activate the energy levels, okay, in carbon dioxide, right, we need to pump. That is what we are telling. That is what we are telling it as one as the active medium. Active medium is carbon dioxide or helium. Okay, and other is the pumping. Pumping means to activate the energy levels in the active medium, we need to pump. That's why it became one of the components for lasing action. Okay, that is what, when we discuss about the components of laser, we need to have about optical cavity, partially reflecting mirrors, and 100% reflecting mirrors, and pumping. Okay, and laser beam. A laser beam is a beam which we get at the output of, right? So these are the different types of lasers. So if you come to the first laser, that is called ruby laser, right? Ruby, we have, as we have seen, the components of laser. One is the active medium and resonating cavity and pumping system. Okay, so pumping system. So these are the different components for a ruby laser. Okay, so these are the different components for what? For a ruby laser, right? Here in ruby laser, the active material, that is what I told you, active medium is made up of some active material, right? That active material is for ruby laser is a ruby crystal, which is taken in the form of a rod, that is what active material or active medium is the ruby crystal in the form of a rod, that is aluminum oxide plus chromium oxide, Al2O3 plus Cr2O3. So this combination will work as a active material. Okay, so this active material is placed in active medium, right? Now, other is the resonating cavity. What do you mean by resonating cavity? A fully reflecting surface at the left end of the ruby crystal and partially reflecting end at the right side of the ruby crystal are to be arranged. Okay. For this, both the ends of the ruby rod are highly polished and painted with silver, such that one end is fully reflecting and other end is partially reflecting. Both the reflecting surfaces are optically flat and are exactly parallel to each other, right? So this is what the resonating cavity is. Okay, so that is what a fully reflecting surface. A fully reflecting surface at the left end of the ruby crystal and partially reflecting end at the right side of the ruby crystal are to be arranged. Okay, for this, both the ends of the ruby rod are highly polished and painted with silver, such that one end is fully reflecting and other end is partially reflecting. Both the reflecting surfaces are optically flat and are exactly parallel to each other. So okay, so that is what the whole mechanism of active material is taking place. Okay, that is in resonate that is in cavity. Okay, so it is the whole mechanism of lasering action will takes place in resonating cavity. Okay, that's what we are telling when we study the active components of laser. So here we have some reflecting mirrors. Okay, the active medium in ruby laser is a combination of both Al2O3 and Cr2O3, right? The combination of these two is taken as active medium. So we need some pumping mechanism to activate the energy levels, or to activate the atoms or electrons in the active medium. Okay, so when they are activated, right? So they start reflecting. Okay, so how the reflection takes place, that we will see in the energy transformations. So when the energy levels are activated, so this energy levels activated will get in the form of lasing beam. Okay, so this lasing beam, so to get the fine order of lasing beam, some partially reflecting mirrors are placed. So see here, if you can see, so this is partially reflecting and this is 100% reflecting. Okay, so this type of cases, that is what we are telling. If fully reflecting surface at the left end of the ruby crystal and partially reflecting end at the right hand of the ruby crystal are to be arranged. That is what, here it is left side and here it is right side are to be arranged. Okay, so for this, both the ends of the ruby rod are highly polished and painted with silver, such that one end is fully reflecting and other end is partially reflecting. Okay, for this, both the ends of ruby rod are highly polished and painted with silver. Dento paint cheyali silver thought, which such that one end is fully reflecting and other end is partially reflecting. Both the reflecting surfaces are optically flat and are exactly parallel to each other. Okay, so this is what the resonating cavity is. Okay, so to activate the energy levels, in the active medium, we need one more parameter, that is called pumping, right? So how this pumping system is worked? Okay, the pumping mechanism involved to activate the energy levels of active medium is the optical pumping. Is what? Is nothing but the optical pumping, right? So what do you mean by optical pumping? Optical pump etla jarugutadi? Optical pumping etla jarugutundi ante, so for this a helical xenon flash lamp with a power supply to pump the chromium +3 ions to higher levels is used. Okay, so the pumping system is the optical pumping system. Okay, for this, a helical xenon flash lamp with power supply to pump chromium +3 ions to higher levels is used. Okay, so see here, this is your ruby rod. Okay, so this ruby rod is surrounded by some flash lamp. Okay, this ruby rod is surrounded by some, so this is your ruby rod. Okay, this ruby rod is surrounded by some flash lamp. This is one lamp, bulb lantidi. Okay, to achieve optical pumping. Okay, so when that is what, for this helical xenon flash lamp with power supplied to pump chromium 3 plus ions to higher levels. So this is ruby rod. Ruby rod is a combination of both Al2O3 and chromium Cr2O3, right? So this combination, the energy levels in this ruby rod to be activated. So to activate the energy levels in the ruby rod, what we need to put a pumping case. Okay, but the pumping mechanism is what we are using is as the optical pumping. So when this optical pumping is done by molding, by putting a xenon flash lamp, in what shape it is? In helical shape. Okay, is it in helical shape? So if you wound a helical, if you wound a ruby rod with flash lamp in helical shape, right, by giving certain energy levels, by giving certain power supply to that particular lamp, okay, then chromium 3 plus ions in this ruby rod will get activated. Chromium plus 3 ions will get activated. Okay, so when this rod is this is a rod, right? So what is this rod? This is a ruby rod. The ruby rod ki em chestamante oka bulb, oka helical xenon flash lamp, flash వచ్చే ల్యాంప్, ఓకే, ఆ రాడ్ కి మనం మౌంట్ చేసి దానికి పవర్ సప్లై ఇస్తే ఆ పవర్ సప్లై ద్వారా ఆ ఫ్లాష్ ల్యాంప్ వచ్చే ఫ్లాష్ ని, ఆ ఫ్లాష్ లైట్, ఆప్టికల్ లైట్ ఏదైతే ఉందో అది ఆ లైట్ ద్వారా అందులో ఉన్న ఆటమ్స్ ఆర్ ఎలక్ట్రాన్స్, ఓకే, అవి అనేవి ఏమవుతాయి? యాక్టివేట్ అవుతాయి. Okay, so those are what nothing but the chromium 3 plus ions to higher energy levels is used. Okay, so this is what the optical mechanism is generally involved. So we shall see how the lasing action takes place, how the energy level or the lasing action takes place. We shall see. That is what we tell about the energy level diagram of ruby laser. So etla energy anedi etta release avutundi, okay, etla energy release avutundi anedi manamu energy transitions etla jarugutunnayi anedi we can see in the ruby rod laser. Okay, clear? So this is the case. Okay, any doubt?
No, sir.
No, sir.
Is it clear?
Yes, sir.
Yes, sir.
So if you have any doubts, you can ask. Is it clear to all of you? So,
Yes, sir.
so in today's class, we started what is metastable state, what is pumping mechanism, what is population inversion. Okay, so what are the components of laser? In the components of laser, we try to enunciate what is the working principle. Okay, so how the lasing action takes place anedi ruby laser lo we'll see in the next class. Okay, lasing action etla jarugutadi, etla energy anedi ruby rod nunchi etla energy anedi bayataku vastadi. Okay, energy etla మనం find out cheyochu anedi we'll see the transition states in the next class. Okay, any doubt? Any doubt? Is it clear?